chemical bonding. Previously we discussed that is B.Sc theory, valence shell electron pair repulsion theory, that discussed that lone pair repulsion that should be much greater than lone pair bond pair and bond pair. Due to this lone pair repulsion is maximum, so we have to draw the structure or predict the structure to keep in mind that lone pair should be maximum distance. Okay. Then, with respect to total number of electrons paired, we have to describe their geometry, their shape, and the nature of the molecules. That should be total number of electron pairs. That is total number of electron pairs. That is number of bond pairs. That should be 2. Number of lone pairs, that should be 0. Geometry or shape, that should be linear. That is BF2, CO2 and BeCl2. Okay. If the total number of electron pairs 2 and number of bond pairs 3 and number of lone pairs, that should be 0. That is trigonal planar, or that is called TBP shape. TBP shape. Trigonal planar. Trigonal bipyramidal, that is called TBP. That is only trigonal planar shape. Okay. That is BF3, LCl3 and SO3. Okay, if number of bond pair, that should be 2, number of lone pair, that should be 1. That must be bend shape, that is B shape, that is SO2, O3, that is ozone, and NO2. As we know, ozone is O, double bond O, single bond O, minus, and that should be plus. That is called ozone. And NO2, that should be N, positive, double bond O, and that should be O negative. Okay. So they are bend shape. Okay. They are bend shape. Okay. Or V shape. Okay. Next one, if total number of electron pairs, that should be 4, number of bond pairs, that should be 4, and number of lone pair, that should be 0, that must be perfect tetrahedral. Okay. Example, CH4, SiF4, NH4 plus. Okay. NH4 plus, that should be undergo, that is perfect tetrahedral. Okay. Perfect tetrahedral. Perfect tetrahedral. Okay. If total number of electron pairs 4, number of bond pairs, that should be 3, number of lone pair 1, then we consider pyramidal shape, that is NH3, PCl3, NCl3 and PH3, phosphine. Okay. If number of bond pairs, that should be 2 and lone pair, that is also 2, as per example H2 and H2S. That is almost V shape. Okay. Okay. Now we consider, that is, if total number of electrons 5, there must be 4 variety. That should be 5 bond pairs, 0 lone pair, that is trigonal bipyramidal. That is called TBP shape. TBP shape, that is PCl5. Okay. If bond pair 4, lone pair 1, that should be SF4. This type of structure. If bond pair 3, lone pair, that should be 2. That is ClF3 and BF3. If bond pair, that is 2, lone pair 3, that should be completely linear type structure. That is called XCF2 and I3 minus and ICl2 minus. Okay. And this ClF3 or BrF3 we can call, okay, ClF3, BrF3, this structure, if you see this is type of T structure, T shape. Okay. We have to notice that geometry and shape are not same. Okay. If we consider geometry, we consider both lone pair and bond pairs. If we consider shape, that is, we only consider bond pair. Only consider bond pair, then we can derive shape. Okay. And the structure which having no lone pair, they must be, for those we consider geometry equal to shape. Okay. total number of electron pairs 6, and number of bond pairs 6, and number of lone pair that should be 0. That is perfect octahedral, that is SF6. Okay. If the number of bond pairs, that is 5, number of lone pair 1, that is BR5 and CLF5. Number of bond pairs 4, number of lone pair 2, that is must be XCF4. Okay. Method of finding the hybridization, that is Z equal to half number of valence electron of center atom plus number of monovalent atom attached to it plus negative charge if present and minus positive charge that should be present. That means number of valence electron of center atom, that must be only for center atom, we consider their valence electron, plus number of monovalent atoms. Monovalent means monovalency. Okay, that is monovalency. Only one electron, basically one electron donate, that is called monovalency, or one bond can be formed, that is called monovalent. Number of monovalent atoms attached to it plus negative charge, if negative charge present then plus added, and if positive charge is present that should be subtract it. Value of Z if 2, that is hybridization SP, that is 2, 3, 4, 5, 6, 7, right? If 2, that is SP, 3 for SP2, 4 for SP3, 5 for SP3D, 6 for SP3D2, and 7 for SP3D3. Okay. Hybridization of nitrogen NH3, if we consider half, that is valence electron 5. Oh, sorry. That is must be 5. And that is number of monovalent atoms, that is hydrogen, number of hydrogen, that should be 3. And that is no negative charge, no positive charge, as the ammonia molecule is a neutral one, so plus 0 minus 0, ultimately 4, that must be 4 means sp3, that is 4 mint S P P and P. Okay, SPPP. Okay, and if SO4 minus, that should be half valence electron of sulfur, we know that is 6, plus number of monovalent, oxygen is not a monovalent, oxygen is equal to divalent. Okay. Oxygen is a divalent. Oxygen is a divalent. Valent. Okay. Oxygen is a divalent, and plus 2 minus charge and 0 for positive charge. That should be sp3. As we know, 4 means sp3. Okay. Last one, that is types of hybridization. If sp is there, sp means if we consider the Z value equal to 2. Okay. Z value 2. There should be Z value 3. Oh, sorry. And there should be Z equal to 4. Okay. That is must SP, that is 1S, 1P. That should be linear. Angle is 180 degree. That is BeCl2, BH2, and C2H2. That should be Z equal to 2, Z equal to 3, and that should be 4. Okay, that is must be SP 1S 1P. Angle 180 degree, linear, that is BeCl2, BH2, C2H2, and SP2 1S 2P, that should be the middle angle, lobes angle, that should be 120 degree, and the triangular planar, that is example BF3, BCl3, C2H4, and CO3 2 minus. Okay, CO2 we know, that is C double bond O negative, I think O negative. That's it. This is the structure. Okay, and sp3, that should be 1s and 3p. That should be tetrahedral CH4, CCl4, SnCl4, and ammonia. Okay, so up to this.